This video is going to show you how to construct a parallelogram using multiple methods. You can construct a parallelogram as long as you know its properties in different ways. So you can use constructions like perpendicular lines or parallel lines if those make sense. You can use midpoints. If we're talking about bisections, you can use transformations such as rotations to help you construct the parallelograms that then maintain their properties and stay parallelograms even if you change the size and shape. So I'm going to look first at how do you construct a parallelogram if you're using the property that the diagonals bisect each other. How could students think about this? This is a great way to assess students. So let's get a geometry sticky out, and I'm going to turn off the labeling. And so one thing, it's diagonal, so diagonals are segments. So if I start with just a segment, and I know I'm going to have to bisect this one diagonal. So bisecting means I need the midpoint. So I can now construct the midpoint by selecting the segment, going over to my options and go to construct a midpoint. So now this segment's been bisected, and I can change the length of this segment, but that midpoint always stays in the middle, right? Always bisects it. So what I need is another segment, another diagonal, that is also going to be bisected by this point. Well, how do I make that happen? Well, I can start with a point and use my understanding of transformations that if I rotate this 180 degrees, these 2 points that then are constructed will form a line, right? 180 degrees is the angle of a line. And I can move the points, but they'll always stay aligned. So let's do that. Let's select this point and let's construct a rotation. So I am using a rotation, understanding of rotation. And I want to notice it says select a point you want to turn around. So I want to turn around this center so that becomes the center of this segment that I'm making. And I want it to be 180 degrees because I'm making a segment or a straight line. Straight segment. So 180 degrees, and when I hit execute, I'm going to get a second point over here, and it's telling me you turned the first point over this midpoint, and now got this image over here that's 180 degrees. And now if I get my segment tool and connect these 2 segments, I now have a second segment, a diagonal, that is bisected by this same midpoint from the original segment. So I now have 2 segments. Notice they are not the same length. That is not a requirement of a parallelogram that our diagonals are congruent. The only requirement is that they bisect each other. And I could measure the distance here and prove that it's bisected, but I know that it's not based on how I know that it is based on how I constructed it. But so I have this condition here that my diagonals are bisecting each other. And so if that's true, this must be a parallelogram. So let's get our polygon tool and connect the 4 vertices. And there is my polygon, and it should be a parallelogram because those diagonals are always bisecting. And so then I could go and test things like, are these 2 sides here parallel? Well, I could measure their slope and I'd find out that it's the same. I could measure these angles and see if the opposite angles are congruent. And all of this would be true because I constructed using a property that has to be true for all parallelograms. So if this property, diagonals bisect each other, is true, then the shape formed from that must be a parallelogram. So that's one way you could construct it. Another way is we could use this, and let's move our directions down just a little bit here. Get another geometry sticky out. And I'm going to turn off my auto labeling again. I'm doing that because I don't like to see the labels. They kind of interfere with what my purpose is. But I could now use this idea of, it's got 4 sides. I've got that. But the sides have to be parallel and congruent. So how am I going to do that? Well, I could start with a segment and another segment, right? These 2 sides are not opposite. They are adjacent. So they do not have to be the same length. What I want is opposite sides. So I need a side here that's going to be parallel and congruent, and I need a side here that's parallel and congruent to this one. So now I'm going to use my construction tools, parallel, perpendicular, to help me do that. So I want a parallel to this side through a point here, right? Because the side I want parallel is going to go through here. So notice the things I selected. The side that I want to be parallel to and the point where I want that other side to go through, right? The other vertex. So I'm going to now go to construct and construct a parallel. So it's going to create, notice it creates a line, which is what we want. It's a line. We're going to find the vertex. We're missing this vertex here. So let's do the same thing. I now want another parallel to this side. So I'm going to select this side, or let's show you how you can use the directions to help you. Let's go to construct and just choose parallel. And it says select a point and a segment. So I want this segment to be the one that it's parallel to, and this point to be where it goes through. And so notice that it constructs that parallel. So now if you look, even if I move it, those opposite sides are always parallel, which means they're also congruent. I could go ahead and measure them. But now let's make this intersection. So we're going to select those two lines that are crossing and construct their intersection. And now when you're doing constructions, a lot of times you create something you don't actually want to see anymore. I don't want to see the whole line. I just want to see this side and this side. So I'm going to actually hide the two lines. So when you select something and go to visible, you can hide those objects. So notice I'm left with just that vertex point. Those lines are still controlling it, but I just don't see them. And now I'm going to get my polygon tool and trace across my vertices so I can see my parallelogram. And so here's my parallelogram, and it's a parallelogram because I constructed it to have opposite sides congruent and parallel. And I could go and measure all the other things to verify that everything else is true, but it would be because I used properties to construct it. So that's just two different ways to think about it. There's so many different ways you could use, rotations. You could do start with just one line and do parallels that way. So lots of ways to think about it. So have fun exploring. This is a great way to assess students' understanding of properties.